Okay, so this is going to be a quick introduction to the autocoder system. And basically, all you need to do is come in here and run it with a description of what you want to build. And so in this case, it's an example with sales data that does transactions from a CSV, figures out regional best categories and products, and detects anomalies, and does statistics and outputs of this report. Okay, so let's go over the nuts and bolts of this system. Is that this initial description, while it's clear to probably the person who asked for it, is not going to always be clear to a coding system. So the first thing it does is it identifies all of the ambiguities and it clarifies them. It'll come up with default answers so that you can just auto run or the user can step in here. Once it's taken the original description and the clarifications, it will generate this new description of what the system to be built is. And then it's going to go from there to a blueprint, like a skeleton of the whole system, that's going to have all of the components, all of the different pieces and functions and how they interact with each other, the specific types of data that they need to be able to process and send to other places. So in this case, you can see we were starting out with a CSV input. We're going to have a component that reads it. It's going to take that data that it read and send it to all of these different, one thing that analyzes product, one thing that analyzes regions, one thing that analyzes anomalies, and we've got to validate the data. But all of this is ultimately sent to a report generator, which then generates a report. Okay, so that's a visual description. The actual blueprint for this that visualization is showing is a file that looks like this, and it's got each different component type, what the inputs, what the outputs are, what the data types are that need to be communicated back and forth, and importantly, it's got sample data for each of those components so that it can test each of these in isolation. So let's talk about why this is important real quick. So the main thing with Cursor and all of these other systems is they work great up until a couple thousand lines of code, and then you run into what I call error cycling hell, where you ask it to fix one problem and it creates another problem, and you just do this over and over again because it doesn't understand the dependency tree of everything that interacts with each other. And part of that is systems like Cursor are not able to inject the compressed version of just the information that the large language model needs to do its job and all of the kind of dependencies in just the right format. But this autocoder system is meant to do that. And the way it does that is it forms a graph of the code base, and not just a graph, but a constrained graph with specific component types that makes this easier for the large language model to handle. So there's these 6 component types. One is a data source, that is where the data comes from, processors that transform the information, routers that send it from one place to another, and there's a few others. But having this constrained architecture helps compress the information into its most simple format and then understand what the dependency tree is, so you're feeding the optimal, compressed, and necessary information to the LLM at every point you go to edit it. When you're building this, there's basically 2 main stages. You have the first stage of building out this blueprint from the user request that outlines the skeleton structure of all of the different pieces of the system and all of the different types of data and their formats, their schemas that you need to send back and forth. Once you figured that out and you validated it and fixed any problems in it, you can move on to the code generation step. And what's really nice about this is that you can write each piece of code, each one of these components in isolation. So if you have a system that involves 100 components, instead of writing all 100 components, testing them, realizing it fails, what you can do is you write one component, you test it. You write the next component, you test it. And then when you put the whole thing back together, because of the way the blueprint works, you know it's going to compose well and everything's going to work once you put it back together. And this gets rid of this problem with scaling that these other systems have. So I'd already run this sales data request, so let me just show you what the output looks like. So you get a project folder here with the sales analytics system. And for each one of these components, the boxes I showed you here, you're going to get a specific file with the code for that box, and each one of these are been individually tested already. The core is just the guts of the system that comes with any generated system. The sales data, every system is going to come with sample data that was used to test the system, so it's easy to see that it's working, but you can substitute in your own data. And it makes it really easy for users to input their own data and adjust all the parameters, because every generated system comes with a parameters.yaml. So you can see it's preloaded with the sample data, but all the user would have to do is just come in here and change out the name of the CSV, and every other configurable parameter is easily modified here, and it's already explained what all of these do. If you wanted a little bit more detail, there's an automatic README that's generated with every file. And I mentioned that a big part of this is defining the format of all of the information that's passed back and forth between these components. So here's like a sales transaction schema, and it's saying these sales transactions need to have all of these different properties. So they need to have the ID, the date, the product ID, the product name, the quantity, the price, the region, the customer ID. So every type of data is already predefined to make testing and scalability easier. And then, yeah, let me just show you what the output of the system looks like. All you have to do to run it is just do Python. You have to be in the right directory first. That is one thing you have to do. So I'm moving into the sales analytics system. And then you just run Python main.py. And this is going to run the system with all of your parameters. And so let's take a look at this. So it created this sales analytic report with regional sales, top products by revenue, sales by categories, anomaly detection. And so again, this is a sample use case, and Cursor probably would have been able to handle something at this level of complexity. This is not a hugely complex program, but the idea behind all of this is creating this constrained architecture that allows large language models to understand exactly the information they need and all the dependencies between the information they need in the most compressed format, and being able to write every single piece of code and test it in isolation, and then build up all the full system from each of these individual pieces in a way that you know it works. So this is a system that scales far beyond where traditional systems like Cursor or Quad Code can do. All right, thank you.